5:15 in the morning. The central Persian Gulf, 40 miles south of the Iranian coastline. The destroyer, DDG-87, USS Mason, was maintaining a steady speed of 15 knots when the first pressure wave hammered the hull from below the waterline. The ship did not merely shake, it bucked upward, 6,000 tons of steel lifted by a massive displaced volume of water. On the bridge, the deck jumped 6 inches, throwing the watch officers against the consoles and shattering the glass of the primary radar displays. There had been no wake, no torpedo warning, and no surface contact. The morning air over the Gulf was heavy with humidity and the faint, lingering scent of diesel from the night's patrol. Within seconds, that stillness was replaced by the deafening roar of the general quarters alarm and the high-pitched scream of steam escaping from a ruptured line in the forward engine room. 2 miles to the east, the destroyer DDG-97, USS Halsey, suffered an identical strike. A massive underwater detonation occurred directly beneath its sonar dome, sending a column of white water 60 feet into the air. 4 seconds later, the third vessel in the formation, the destroyer DDG-107, USS Gravely, was hit near its stern. The explosion was so powerful that it sheared the port-side propeller shaft completely off its mounts, sending a violent vibration through the entire length of the ship that rattled teeth and snapped steel bulkheads like dry wood. In less than 10 seconds, 3 of the most advanced warships in the United States Navy had been neutralized in a coordinated, silent strike. The primary protagonist of this engagement, the ARLEIGH BURKE-class destroyer, was designed to fight off swarms of aircraft and batteries of anti-ship missiles. However, the threat that had just manifested was something entirely different. It was the Shahid-U network, a secret grid of autonomous underwater vehicles that had been pre-positioned on the sea floor weeks in advance. These drones were not active seekers. They were bottom-dwelling mines with intelligent acoustic sensors, waiting for the specific signature of American turbine engines to pass overhead. Aboard the USS Mason, the situation was critical. The commanding officer arrived on the bridge to find a scene of controlled chaos. The internal communications system was intermittent, but the reports coming from the damage control center were grim. The blast had occurred near the forward auxiliary machinery room. Seawater was rushing in at a rate of 400 gallons per minute. The thick, salty air of the Gulf was now being sucked into the ship through the jagged hole in the hull, mixing with the acrid smell of burning electrical insulation and hydraulic fluid. Tactically, the 3 ships were now sitting ducks. The formation had been shattered. While the Aegis Combat System remained powered, the ship's ability to maneuver was severely compromised. On the Mason, the forward gas turbine engines had been knocked offline by the shock of the blast, leaving the ship running on emergency diesel generators. The sonar technicians, those who were not injured by the initial shockwave, struggled to make sense of their displays. The water around the ships was a chaotic mess of bubbles, debris, and the fading echoes of the 3 explosions. But as the noise began to settle, a terrifying realization emerged. The 3 drones that had detonated were only a small part of a larger swarm. Passive sonar began to pick up dozens of faint, rhythmic whirs, the sounds of small, high-efficiency electric motors. These were not stationary mines. They were mobile, low-speed drones, dozens of them, converging on the crippled American ships from all directions. The Iranian Navy had turned the shallow, cluttered waters of the Persian Gulf into a lethal graveyard, using a technology that cost less than a single American interceptor missile. On the Mason's bridge, the tactical action officer stared at the secondary monitor. The blue icons representing the 3 United States destroyers were surrounded by a ring of red dots, appearing and disappearing as the drones moved in and out of the thermal layers of the water. The drones were moving at only 5 knots, but they were numerous and silent. The crew of the Mason scrambled into their flash gear, the fire-resistant hoods and gloves that signaled the shift from a ship in transit to a ship at war. The sound of heavy boots hammered against the non-skid deck as damage control teams hauled heavy Pone 100 pumps toward the flooding compartments. The heat below decks was rising rapidly, reaching over 100 degrees as the ventilation systems failed. The mission had changed in an instant, from a routine freedom of navigation patrol to a desperate struggle for survival. The United States Navy was facing a ghost network an invisible enemy that did not use radar or radio, making it nearly impossible to target with conventional weapons. As the sun began to peek over the horizon, casting a long, golden light across the oil-slicked water, the sailors of the Fifth Fleet realized that the battle for the Persian Gulf had just begun, and they were already fighting from a position of devastating weakness. 6:25 in the morning. The sonar shack of the USS Mason and the Joint Intelligence Center in Bahrain. Sonar technician First Class Miller was staring at a waterfall display that should not have made sense. The screen was a cascading river of green and blue light, representing the acoustic environment of the Persian Gulf, but the data was being drowned out by the ship's own trauma. The sound of the Mason's hull groaning under the weight of incoming seawater and the rhythmic thumping of the portable diesel pumps created a wall of white noise. Yet, Miller was looking for a ghost, the specific frequency of the machine that had nearly split his ship in half. The air in the sonar shack was cool and dim, smelling of stale coffee and the sharp, ozone-scented exhaust of the electronics cooling system. It was a stark contrast to the sweltering, smoke-filled machinery spaces below, but the tension was just as high. Miller adjusted his headset, filtering out the low-frequency rumble of the ship's emergency generators. He was looking for a pattern, a repetition, something that suggested a mechanical heart beating in the dark water. He found it at exactly 6:28. It was a faint, rhythmic pulse, oscillating at 62 Hz. It was so subtle that it would have been dismissed as background biological noise, a school of fish, or shifting sands if it hadn't been moving with purpose. He isolated the signal and ran it through the master acoustic library, the massive database of every known engine signature in the world maintained by the Office of Naval Intelligence. The computer took 3 seconds to return a match. The screen flashed a yellow warning. Signature match confirmed. Iranian Shahid-U series. Autonomous underwater vehicle. Miller's voice was steady as he relayed the information to the bridge. He reported that the drones were not using traditional propellers. Instead, they were using high-efficiency electric rim-driven thrusters, which allowed them to move with almost zero acoustic cavitation. This was why the Mason's passive sonar had failed to detect them until it was too late. These drones were designed to be invisible, to the very sensors meant to protect the fleet. Simultaneously, 300 miles to the west in Bahrain, analysts at the Fifth Fleet headquarters were piecing together the larger ghost pattern. They were receiving high-speed data bursts from the Mason, the Halsey, and the Gravely. By triangulating the locations of the detonations and the faint sonar contacts now being reported, the intelligence officers realized they weren't dealing with a few random mines. They were facing a sophisticated, self-organizing mesh network. The Shahid-U drones were communicating with each other using low-frequency acoustic modems. They didn't need a mothership or a pilot. They were programmed with a swarm logic that allowed them to distribute themselves across a wide area and wait. When one drone detected the specific acoustic signature of an American ARLEIGH BURKE-class destroyer, it would signal the others. The network would then calculate the ship's course and speed, and the nearest drones would activate their thrusters to intercept. The tactical implications were devastating. The Persian Gulf was effectively a minefield that could move. The analysts identified at least 4 distinct clusters of these drones, totaling perhaps 60 to 80 individual units, positioned at key choke points along the transit lanes. The commanding officer of the Fifth Fleet was briefed on the situation at 6:45. He was told that the drones were likely launched weeks ago from civilian D-hows or small fishing boats, sinking to the bottom and entering a low-power sleep mode. They had been waiting for the signal to activate, which had likely been sent via an underwater acoustic trigger from a passing Iranian submarine or a shore-based station. Naval intelligence now had a name for the enemy, but the problem remained. The drones were too small and too quiet for the destroyer's standard Mark 54 torpedoes to track effectively. The ships were essentially trying to shoot mosquitoes with sledgehammers. To survive, the Navy would have to change its entire defensive posture in a matter of minutes. Miller watched his screen as 4 more red dots appeared on the periphery of the Mason's sonar range. They were closing at 5 knots, moving with the cold, calculated patience of a machine. He knew that every time his ship's pumps cycled, they were broadcasting a kill me signal to the swarm. The ghost was no longer a mystery. It was a predator, and it was closing in for the finish. 7 in the morning. Naval Support Activity, Bahrain. The headquarters of the United States Fifth Fleet. The Maritime Operations Center was a theater of crisis. The room was dominated by a wall of 30-foot digital displays, each one pulsing with real-time data from across the Persian Gulf. In the center of the room, the Vice Admiral commanding the Fifth Fleet stood before the primary tactical map. The blue icons for the Mason, the Halsey, and the Gravely were flashing amber, signaling their damage status. Around them, the ghost pattern of the Iranian drone network was being rendered in a shifting cloud of red icons, based on the latest acoustic data. The air in the command center was climate-controlled to a crisp 68 degrees, but the atmosphere was suffocatingly tense. The only sounds were the low murmur of watch officers on secure headsets and the rhythmic clicking of keyboards. The scent of floor wax and high-end electronics filled the space. The Vice Admiral turned to his Director of Operations. His voice was calm, but his words were sharp and decisive. He ordered the immediate establishment of Operation Silent Shield. The primary objective was not just to rescue the 3 crippled destroyers, but to create a defensive corridor that would prevent the Iranian swarm from expanding its reach toward the carrier USS Gerald R. Ford, which was currently operating 100 miles to the south. The Fifth Fleet coordinated a massive regional response. Orders were flashed via encrypted satellite link to every American asset in the region. The cruiser CG-73, USS Port Royal, was ordered to flank at 30 knots to provide a localized air and sea surface defense umbrella for the wounded destroyers. From Naval Station Rota and bases in the United Arab Emirates, P-8 Poseidon maritime patrol aircraft were scrambled to provide eyes in the sky. The command center analysts were working to define the engagement zone. They realized that the drones were operating in a kill grid roughly 60 miles wide. The Vice Admiral authorized the use of acoustic chaos's tactics. This involved deploying every available tugboat, support vessel, and helicopter to the area to drop high-intensity acoustic noisemakers into the water. The goal was to saturate the drone's sensors with so much false data that they would be unable to lock onto the specific signatures of the American warships. At 7:15, the first warning to mariners was broadcast on all maritime frequencies. The United States Navy declared a total exclusion zone in the Central Gulf, ordering all civilian traffic to clear the area immediately. This was not just for the safety of the civilian ships. The Navy needed the acoustic environment to be as clean as possible to track the small electric motors of the drones. Logistics officers were already calculating the requirements for a massive recovery operation. They coordinated with the heavy-lift ship Blue Marlin, currently in the Indian Ocean, to begin steaming toward the Gulf. They also contacted commercial diving contractors in Dubai to prepare for emergency hull repairs. The Vice Admiral knew that the Mason and the Halsey were only a few compartments away from sinking. The most critical part of the plan, however, was the establishment of the inner screen. The Fifth Fleet headquarters ordered a squadron of Mark VI patrol boats to depart from Bahrain. These fast, agile vessels were equipped with high-resolution side-scan sonar and depth charges. Unlike the heavy destroyers, these boats could maneuver in the shallow waters where the drones were most effective. By 7:30, the regional response was in motion. A defensive perimeter was forming around the 3 destroyers, comprised of a multi-layered shield of ships, aircraft, and electronic warfare assets. The Vice Admiral watched the screen as the blue icons began to move, converging on the point of impact. "This is no longer a rescue mission," the Vice Admiral said, his eyes fixed on the red cloud of drones. "We are going to find every one of those machines and turn them into scrap metal before they find another target." The command center hummed with the energy of a superpower, focusing its immense strength on a single, lethal problem. The professional machinery of the United States Navy was fully engaged. They had identified the threat, they had established the command structure, and they were now preparing to strike back. But the Iranian network was not static. As the American shield began to form, the swarm logic of the Shahid-U drones was already calculating its next move, looking for a gap in the armor. 7:45 in the morning. The sky over the central Persian Gulf was a pale, hazy blue, the horizon shimmering with the first real heat of the day. High above the oil-slicked water, two Poseidon maritime patrol aircraft circled at 5,000 feet. Inside the pressurized cabins, the air was cool and smelled of electronic coolant and recycled oxygen. Sensor operators sat before glowing banks of monitors, their hands hovering over trackballs. They were dropping a wall of sonar buoys, dozens of cylinders launched from the belly of the aircraft, that parachuted into the sea, deployed a hydrophone on a long cable, and began transmitting acoustic data back to the aircraft via radio link. The Pate crew was working in tandem with three MH-60 Sierra helicopters from the carrier USS Gerald R. Ford. The helicopters hovered just 50 feet above the surface, their rotors kicking up a violent spray of salt and mist. From their side doors, they lowered dipping sonar transducers, heavy, bell-shaped sensors that plunged into the depths to listen for the specific 62 Hz hum of the Iranian drones. The aerial hunt was a race against time. The sonar technicians on the Pate identified three distinct clusters of drones, each containing 12 to 15 units. These clusters were moving in a staggered V formation, gliding through the thermal layers where the water temperature changed abruptly, which helped hide their acoustic signature from surface ships. The sensor operators on the aircraft mapped these clusters in real time, feeding the coordinates directly into the Cooperative Engagement Capability Network. Contact Sierra 14 confirmed Shahid-U signature. The lead Pate operator reported, depth 40 meters, speed 5 knots, course 010. They are closing on the Halsey's stern. The air crews were not just observing, they were marking the targets for the inner screen of patrol boats. The helicopters dropped smoke flares onto the surface to provide a visual reference for the surface teams. The smell of burning phosphorus from the flares drifted across the water, mixing with the salt spray. The coordination was flawless. The Pate provided the wide area God's eye view, while the helicopters provided the precision tracking. Every time a drone cluster moved, the aerial sensors updated the grid. The sensor operators could see the drones clearly, now small, torpedo-shaped shadows moving through the dark green water of the Gulf. The humidity was rising, making the air thick and heavy. But the technology of the United States Navy was cutting through the haze. The aerial hunt had stripped away the drones' primary advantage, their invisibility. The ghosts were now targets. Below the aircraft, the first of the Mark VI patrol boats arrived at the edge of the exclusion zone, their bow waves cutting through the water at 40 knots. They were guided by the voice of the Pate controller, who vectored them toward the smoke flares. The hunt was transitioning from detection to engagement. The sailors in the aircraft and helicopters watched their screens, knowing that the next few minutes would determine if the three crippled destroyers would survive the morning or be sent to the bottom by the second wave of the swarm. 8:15 in the morning. The defensive perimeter around the naval warship. The military patrol boat, designated Coastal Command Boat 3, hit the first waypoint at 45 knots. The air was a screaming gale of salt spray and the smell of high-octane marine diesel. Guided by the maritime patrol aircraft's telemetry, the boat's weapons officer slewed the aft-mounted depth charge rack into position. The sensor screen showed a cluster of 6 underwater drones just 20 meters below the keel, rising rapidly for an intercept. "Weapons free," the captain commanded. The first depth charge rolled off the rack with a heavy, metallic clunk. It hit the water with a white splash and sank instantly. 3 seconds later, the sea behind the boat erupted. A massive dome of white water, 300 feet wide, surged upward as the 500-pound explosive charge detonated at depth. The physical shockwave was a literal wall of pressure that slammed into the hull of the patrol boat, lifting the stern 2 feet out of the water and nearly throwing the crew from their shock-mitigating seats. The sound was not a bang, but a deep, bone-crushing thud that vibrated through every human ribcage in the compartment. The warhead's pressure wave punched straight through the lightweight composite hulls of the 3 nearest foreign drones. They did not just break. They were obliterated. Fragments of carbon fiber and lithium-ion battery cells were sent flying through the water. creating a cloud of black debris that surged toward the surface. One drone's battery bank short-circuited instantly, causing a secondary 22 Azasek underwater flash of brilliant, eerie green light that bleached the dark water for a split second. The remaining 3 drones in the cluster did not retreat. Their swarm logic detected the patrol boat's acoustic signature and calculated a lead pursuit intercept. One drone wrenched, its nose upward, its electric motor screaming at maximum revolutions. It broke the surface 5 meters from the patrol boat's port side, its proximity fuse sensing the steel hull. The drone erupted in a massive fireball of chemical fire and high explosives. The blast wave shattered the patrol boat's portside windows and shredded the reinforced plastic of the gun tub. The heat was an instantaneous, searing lash that blistered the paint on the superstructure and washed across the face of the gunner, who was saved only by his ballistic visor. The smell of burning rubber and acrid, scorched electrical components filled the air in a choking cloud. The patrol boat lurched violently to the right, its port engine coughing and then dying, as the intake sucked in a mix of fire and salt water. Black smoke poured from the shattered hull plating near the waterline. On the bridge, the radio erupted with overlapping voices as the crew scrambled to assess the damage. The surface of the Gulf was now a chaotic mess of white foam, floating debris, and the dark, oily stains of the destroyed drones. The immediate area fell into a heavy, ringing silence, broken only by the hiss of the remaining engine and the distant roar of the naval warship's pumps. The second wave had been intercepted, but the cost was written in the jagged, blackened hole in the patrol boat's side. 9:15 in the morning, the central Persian Gulf and the Iranian coastline near Bandar Abbas. While the destroyers fought for buoyancy, the cruiser CG-73 USS Port Royal received the execute order from 5th Fleet. The ship was slicing through the water at 28 knots, its massive ANSPY-6 radar arrays scanning the horizon for any sign of Iranian air intervention. Deep within the ship, in the Mark 41 vertical launch system, the sequence was initiated. The first Tomahawk cruise missile ignited with a roar that shook the entire forward deck. A pillar of white smoke and orange flame punched upward, the heat instantly vaporizing the morning humidity. The missile cleared the deck in a second, its wings unfolding as the solid rocket booster accelerated it toward the coast. Within 2 minutes, 12 missiles were in the air, flying low just 50 feet above the wavetops, following the contours of the sea to avoid radar detection. The targets were 3 reinforced concrete bunkers hidden beneath the rocky cliffs of the Iranian coast. These were the nerve centers for the drone network, housing the high-frequency acoustic transmitters and the satellite uplinks used to coordinate the swarm. The air near the coast was dry and smelled of dust and sun-baked stone, a sharp contrast to the salt spray of the open Gulf. The first Tomahawk reached its target at 9:24. The missile's 1,000-pound warhead punched through the 2-meter-thick back, reinforced concrete roof of the primary control bunker before detonating. The internal explosion was catastrophic. A massive plume of gray dust, fire, and shattered equipment erupted from the bunker's ventilation shafts. The shockwave was so powerful, it caused a localized rock slide, burying the entrance in hundreds of tons of limestone. Inside, the servers and acoustic modems that had been directing the ghost drones were reduced to molten slag in less than a millisecond. The second and third bunkers were hit seconds later. One missile struck the auxiliary power station, causing a massive electrical arc that bleached the sky white for 3 full seconds before a secondary explosion of diesel fuel tanks sent a rolling ball of black smoke 500 feet into the air. The smell of burning chemicals and pulverized concrete drifted over the coastal road, which was now empty of civilian traffic. The response was immediate but disorganized. A battery of surface-to-air missiles was fired from a nearby ridge, their white exhaust trails crisscrossing the sky. One missile managed to intercept a Tomahawk, resulting in a brilliant flash of light as both exploded 4 miles offshore. However, the remaining 10 missiles found their marks. Back in the Gulf, the effect on the drone network was instantaneous. On the sonar screens of the naval warship, the swarming behavior of the red dots stopped, Without the coordination signals from the shore bunkers, the drones defaulted to their fail-safe mode. They stopped their high-speed intercepts and dropped to the seafloor, entering a stationary passive state. The rhythmic 62 Hz hum that had haunted the sonar technicians for hours faded into the background noise of the sea. The kinetic strike had severed the head of the snake. The immediate tactical threat to the 3 destroyers had been neutralized, but the cost of the engagement was rising. Black smoke from the coastal strikes was visible from the ship's bridge, a dark smudge on the northern horizon. The silence that followed the explosions was heavy, filled with the realization that the conflict had just escalated from a localized drone attack to a direct strike on sovereign territory. 10:45 in the morning. The central Persian Gulf. The combat phase had passed, replaced by the grueling, high-stakes physics of a mass casualty recovery operation. The air was now a stifling heat, reaching 98 degrees with 90% humidity. It smelled of heavy fuel oil, salt, and the copper tang of blood. On the deck of the USS Mason, the primary flight deck had been converted into a triage center. 2 MH-60 Sierra helicopters sat with rotors turning, the downwash providing the only relief from the sun as corpsmen loaded 3 critically injured sailors onto litters. The logistics of survival were being coordinated by the fleet oiler, TAO-18, USNS Bighorn, which had arrived on station to provide emergency power and pumping capacity. The most delicate operation was the underway replenishment of materials rather than fuel. Heavy-duty towing hawsers, braided nylon ropes, 5 inches thick, were being shot across the gaps between the ships using pneumatic line throwers. The USS Mason was now listing 5 degrees to port. To keep the ship from capsizing, the engineering officer ordered a counterflood. This involved intentionally allowing 400 tons of seawater into the starboard compartments to level the ship. It was a terrifying gamble. The ship sat lower in the water, with only 3 feet of freeboard remaining at the midsection. Every time a swell hit, the Gulf washed over the deck, soaking the sailors who were struggling to secure the massive towing cables. The USS Gravely was in even worse shape. Because its steering was jammed and its hull was compromised at the stern, it could not be towed in a straight line. A seagoing tug, the USNS Apache, had to hip-tow the destroyer, lashed tightly to its side like a wounded animal. The sound of the 2 steel hulls grinding against each other, separated only by massive rubber fenders, was a constant, shrieking moan that echoed through the ships. Logistics also meant the management of the crew's endurance. The sailors had been at battle stations for over 5 hours in suffocating heat. Supply teams moved through the ship, distributing go pills, bottled water, and high-protein rations to men who were too exhausted to leave their posts. In the flooded engine rooms, the work continued in shifts. Teams of hull technicians, wearing scuba tanks to breathe through the smoke, worked beneath the oily water to weld soft patches over the smaller leaks. The most critical logistical challenge was the tow-ex to the port of Jebel Ali in the United Arab Emirates. The formation could only move at 4 knots. At this speed, the 100-mile journey would take 25 hours. During every minute of that transit, the ships were vulnerable. To protect them, the USS Port Royal and a screen of 4 patrol boats maintained a tight circle, their sonar systems pinging continuously, to ensure no sleeper drones remained in their path. By 11:30, the tow lines were taut. The Apache and the Bighorn began the slow, agonizing process of pulling 18,000 tons of crippled American steel toward safety. The sea was running a 1-meter swell, causing the tow lines to snap and groan with thousands of pounds of tension. One miscalculation in speed or a sudden change in current could snap a cable, sending it whipping across the deck with enough force to decapitate anyone in its path. The professional discipline of the logistics teams was the only thing preventing a secondary disaster. There was no glory in this work, only the methodical application of seamanship and mechanical engineering under extreme duress. As the slow-motion convoy began to move south, the crews looked back at the oil slicks and debris that marked the site of the ambush. They were alive, and their ships were still afloat, but the path to the shipyard was a long, dangerous road of salt and iron. 12:30 in the afternoon, 30 miles south of the Iranian coastline. The water of the Persian Gulf, usually a translucent turquoise, was a dark, opaque green at a depth of 50 meters. In the silence of the deep, the only sound was the faint, rhythmic whirring of the REMUS 600 unmanned underwater vehicles, or UUVs. These yellow, torpedo-shaped machines were the scouts for the final phase of the operation, the Scorched Earth Sweep. Launched from the stern of a specialized Navy SEAL support vessel, the UUVs utilized synthetic aperture sonar to map the sea floor in high resolution. They were looking for the eggs, the remaining dormant Shahid-U drones that had not yet been activated. The sensors on the REMUS units could distinguish between a natural rock formation and the smooth, man-made composite of an Iranian drone, even when the latter was partially buried in the silt. Aboard the support ship, the air in the command van was cool and smelled of salt air and high-end computer servers. Navy SEALs from Unit 2, specializing in undersea sabotage and mine clearance, monitored the data feeds. When a REMUS unit flagged a high-probability target, the SEALs deployed a Seafox neutralization drone. The Seafox was a small, wire-guided vehicle equipped with a shaped charge explosive. It moved through the water with precise, jerky motions, its camera feed showing a grainy, greenish view of the seabed. At 12:45, the camera settled on a dark, cylindrical shape lodged in a crevice. It was an unactivated Shahid-U drone, its acoustic sensor pointing upward like a blind eye. The SEAL operator in the command van manipulated a joystick, bringing the Seafox within 3 feet of the target. Target confirmed. Initiating neutralization, he said. The Seafox drove itself directly into the Iranian drone. There was no massive surface explosion, only a muffled thump that sent a cloud of silt and bubbles rising through the water column. On the sonar display, the red icon representing the drone vanished. This process was repeated dozens of times over a 12-mile grid. The SEALs were not just clearing a path, they were conducting a forensic sweep. They used robotic arms to recover 2 intact drones, carefully lifting them into specialized containment cradles to be transported back to the United States for exploitation and reverse engineering. The air on the deck was hot and thick with the smell of wet mud and seaweed as the dripping, salt-encrusted machines were winched aboard. The Scorched Earth Sweep was a grueling, repetitive task that required absolute concentration. Each drone destroyed was a potential future casualty prevented. By mid-afternoon, the SEAL teams had neutralized 24 dormant units. The sea floor was littered with the shredded remains of the Iranian network carbon fiber fragments and crushed electronics settling back into the sand. As the sun began its descent toward the horizon, the SEAL support vessel maintained its station, its crew working with the quiet, lethal efficiency of a surgeon. They had taken the Ghost out of the water, replacing it with the cold reality of American undersea dominance. The network was broken, its nodes destroyed or captured, and the secret weapon that had nearly crippled 3 destroyers was now a collection of scrap metal and intelligence data. 18 hours after the first detonation, the headquarters of United States Naval Forces Central Command, Bahrain. The evening air over the Persian Gulf was a bruised purple, the heat of the day finally beginning to bleed into a cool, salty breeze. In the Maritime Operations Center, the frantic energy of the morning had settled into the heavy, methodical pace of a post-combat assessment. The Vice Admiral stood at the same glass railing where the day had begun, looking down at the rows of analysts who were now compiling the final report for the Secretary of Defense. The strategic summary was a testament to the brutal efficiency of the Shahid-U ambush and the professional resilience of the United States Navy. The 3 ARLEIGH BURKE-class destroyers, the Mason, the Halsey, and the Gravely had all survived, though they were currently being towed at a snail's pace toward the dry docks of Jebel Ali. The cost of their survival was written in the casualty lists now being finalized. 11 sailors were confirmed killed in action, mostly from the initial blasts in the engine rooms and the subsequent flooding. 42 others were injured, 6 of them critically. The drone network had been a tactical success, but a strategic failure. While they had managed to damage 3 frontline warships, the military response had been overwhelming. Over 60 autonomous underwater vehicles had been neutralized by depth charges or Navy SEAL demolition teams. More importantly, the kinetic strikes on the coastal control bunkers had effectively blinded the foreign military's undersea warfare capability in the Central Gulf for the foreseeable future. The restoration of maritime deterrence was the primary focus of the evening's briefings. The carrier, USS Gerald R. Ford, had moved into the Central Gulf, its flight deck, a constant cycle of FA-18, Super Hornet launches and recoveries. The message was clear: the military would not be forced out of the regional waters by ghost technology. The exclusion zone remained in place, and the Navy announced that all future transits would be preceded by unmanned scout vessels specifically designed to trigger and neutralize underwater drones. Naval intelligence had already begun the process of exploitation on the 2 intact drones recovered by the SEALs. Preliminary analysis suggested a sophisticated mix of commercial off-the-shelf electronics and custom-built acoustic modems. The findings were already mixed from SO, being used to update the software for every sonar system in the fleet, ensuring that the 62 Hz ghost signature would never be invisible again. The Vice Admiral signed the final sitrep at 2100 hours. He knew that this engagement was a harbinger of a new kind of warfare, one where the ocean floor was as much a battlefield as the air or the surface. The era of the unseen swarm had arrived, and while the Navy had held the line this time, the margin of victory had been razor thin. As the digital clocks in the command center rolled over to the next day, the blue icons for the Mason, the Halsey, and the Gravely reached the outer marker of the port. The crews on the decks looked toward the lights of the city, their faces caked with salt, soot, and exhaustion. They had faced a phantom in the dark and had brought their ships home. The battle for the Gulf was over, but the silent watch continued.